The force of one of these space rocks is equivalent to 10,000 Hiroshima bombs. This immense power is contained in a piece of genuine space rock, about a mile across, named Oumuamua. This baffling object, which once zipped through our solar system, has again sent shock waves throughout the scientific community. Elon Musk, a prominent figure in space innovation, revealed that Oumuamua is back, and this time, it's not alone on its journey. Musk claims that its mysterious properties contain an intriguing clue about life in other star systems. This isn't the usual return of a celestial body, it's a return that challenges our understanding of space and its true potential. Let's explore the implications and secrets surrounding Oumuamua's startling return. Back in 1837, a strange object reached a significant astronomical milestone. It crossed a distance of 1,000 galactic units from the Sun. For over a century, this object continued its journey, remaining unnoticed as it traveled toward our star. It wasn't until October 19, 2017, that humanity became aware of its presence. On that day, an image captured by the Pan-STARRS 1 telescope at the University of Hawaii revealed a faint, elongated streak crossing the sky at a consistent speed of around 6.2 miles per second. This marked a notable moment. It was the first recorded interstellar visitor, officially designated as 1I/2017 U1, and also given the name Oumuamua, which means scout or messenger in Hawaiian. The discovery sparked a global effort to observe Oumuamua through telescopes. Stargazers, including those from the SETI Institute, eagerly engaged in observing the object, even launching searches for possible extraterrestrial signals. Oumuamua appeared as a reddish, cigar-shaped object composed of rock. Its elongated shape is remarkable, stretching about 4 times longer than it is wide. Its aspect ratio surpasses any asteroid or comet seen in our solar system. Oumuamua was traveling at a speed of 196,000 miles per hour as it approached Earth, about 26 times faster than a bullet, indicating that it was not part of our solar system. Initially, scientists couldn't determine whether Oumuamua was an asteroid or a comet. Comets are made of ice, while asteroids are composed of rock. Initially thought to be a comet, its classification changed to an asteroid once it passed the Sun on September 9, 2017. However, its slight acceleration suggested it might actually be a comet. One remarkable feature of Oumuamua was its periodic brightening and dimming every 7.3 hours, indicating its rapid rotation. This rapid rotation suggested a more rigid and durable composition than the typically fragile, snow-like material of most comets. Its reddish color, similar to certain moons in the outer solar system, could also imply the presence of iron, as suggested by Dr. Meach, an astronomer at the University of Hawaii. Despite these insights, the origin and nature of Oumuamua remain a mystery. Its trajectory puzzled scientists, hinting at something beyond conventional explanations. Various hypotheses emerged to explain its nature. Some believed it was a rock, others proposed it might be made of gas, and intriguingly, a subset of scientists even considered the possibility that it could be an alien spacecraft. This raises the fascinating question: could an extraterrestrial mothership be exploring our solar system and sending smaller probes to investigate planets? In the next section, we'll delve deeper into these mysteries. However, first, let's explore the range of scientific proposals that have been advanced to explain Oumuamua's origin. Dr. Meach proposed that it could have been ejected from a distant star following a supernova explosion or formed from the collision of two objects. According to Elon Musk, astronomers were initially excited when they observed that the trajectory appeared to point toward Vega, a bright star in the Lyra constellation, known to have a debris disk. Computations suggested that Oumuamua might have traveled from Vega to our solar system in about 600,000 years. However, the likelihood of Vega being the actual source has diminished due to significant changes in its trajectory. It is now believed that Oumuamua might have encountered another star system during its journey, considering its movement relative to the Sun, which was likened to the speed of nearby stars. Nevertheless, there is a possibility, as proposed in nature, that Oumuamua could have been wandering the galaxy for billions of years. Imagine this like the way the Voyager spacecraft gained speed from Jupiter. Oumuamua is also gaining momentum from the Sun, propelling it faster and in an unexpected direction. Dr. Meach explained that this space rock, along with its counterparts, alters our perspective on the cosmos. Picture this: when you gaze at distant stars that seem isolated, Oumuamua reveals a different view. It reminds us that the universe is interconnected. Fascinatingly, the oxygen and iron in our blood originated from a distant explosion long ago, and precious elements like gold resulted from the collision of superdense stars. Moreover, some meteorites falling to Earth might have originated from Mars due to asteroid impacts. Surprisingly, some scientists consider the possibility that these meteorites could have carried life from Mars to Earth when Mars had warm and wet conditions. It's a bold idea, but it's being considered by esteemed astronomers. Our connection to the universe extends far back in time. Consider the countless years Oumuamua took to arrive here. While that may seem like a long time, it's just a brief moment on the cosmic scale. The Milky Way galaxy is about 10 billion years old. Over this immense period, Oumuamua could have traversed roughly 20,000 star systems, a small fraction compared to the galaxy's 200 billion stars. Yet, despite its vast journey, Oumuamua's arrival reminds us that the universe may be smaller and more interconnected than previously thought. Although it is now distant, our solar system has not given up on it. Elon Musk and other scientists predict that Oumuamua will enter the Kuiper belt around 2024 and cross its edge by late 2025. He also estimates that it will pass its most distant point in 38 years. However, since Oumuamua is far away, astronomers are making the most of the data collected in just a few months to understand as much as possible about this captivating interstellar visitor. Initially mistaken for an asteroid due to its size, about 2,600 feet long and 260 feet wide, Oumuamua exhibited peculiar behavior in its trajectory. Scientists and researchers observed a striking non-gravitational acceleration, indicating that forces beyond gravity were at play. Past gravitational influences were affecting everything in its movement. Dr. Meach made sense of the fact that a few variables could prompt this speed increase. Her group examined at least 6 potential causes, dismissing some due to their improbability or inconsistency with observations. One likely explanation was comet outgassing, a common occurrence in comets. Outgassing happens when a comet approaches the Sun, causing its surface ice to vaporize directly from solid to gas. This process gives the comet an extra push, altering its speed and rotation beyond gravitational influence. This change in movement resembles the behavior of Oumuamua, aligning with the forces observed in comets. Note that the absence of visible dust from Oumuamua was intriguing. Normally, as gas leaves a comet, it carries surface dust with it. However, Dr. Meach declared that even if the comet lacked tiny material, the presence of larger dust particles on its surface could have been affecting its speed. This idea kept the possibility of Oumuamua being a comet alive. Furthermore, researchers primarily examine visible frequencies, making it difficult to detect large dust particles. Therefore, no visible evidence of dust leaving Oumuamua was noticed. The absence of gas-related signs was also puzzling. Astronomers expected to observe a significant amount of gas release affecting Oumuamua's speed in the manner observed. Dr. Meach's group specifically searched for CN gas, which she notes is bright and easily detectable. CN serves as a proxy for water, which is harder to monitor since CN is often released from comets in our solar system alongside water. Strangely, despite their efforts, no CN gas was detected within their detection limits. Given that comets in our solar system often hold large amounts of water, the strong upper limit set by the absence of CN gas indicated that this comet was chemically unique. Dr. Meach explained that if a large volume of water were to be released, it would likely originate from a different star system, potentially explaining this surprising finding. Astronomers used the Spitzer Space Telescope to observe Oumuamua in the infrared for over 30 hours, attempting to detect its thermal properties. However, they encountered challenges in this endeavor. Dr. Meach explained that thermal infrared detects heat emissions, but in this case, their observations did not yield any noticeable results. Interestingly, even non-detections can offer insights. In this case, they found that Oumuamua should be brighter than expected if it exhibited thermal behaviors similar to a comet. The reflectivity of an object, or the amount of light it reflects, can reveal details about its size, structure, and shape. We always assume the reflectivity resembled that of comets, which is very low, Meach explained. However, they were getting readings around 10% reflectivity instead of the typical 4% reflectivity of comets. So once again, it didn't quite fit the profile of a comet. To make it match that 4% reflectivity, you'd have to assume it had significantly different thermal properties on its surface compared to other comets. This is another fascinating peculiarity. Moreover, during the same infrared studies, no detectable carbon monoxide or carbon dioxide outgassing from Oumuamua was seen. This finding is significant since Meach's team had been considering the possibility that Oumuamua was releasing these two gases in larger amounts than Spitzer's detection limit. According to Meach, it's a little challenging to infer too much from what you don't detect, but again it doesn't seem to behave like a typical comet. Given that Oumuamua hailed from a different star system, these anomalies could be typical for objects originating from other stellar systems. The trajectory of Oumuamua was carefully traced back to before its initial entry into our solar system by Corin Baylor-Jones from the Max Planck Institute for Astronomy. Comparing this path with the past positions of 7 million stars tracked by the Gaia spacecraft, Baylor-Jones rewound both Oumuamua-S and the star's orbits to identify potential overlap points. Among the stars with trajectories that approached close enough to Oumuamua-S rewound path, 4 candidates stood out as possible candidates for its home. Elon Musk claims that Oumuamua-S trajectory had crossed within a range of 1 to 2 Oort cloud distances, or 100,000 to 200,000 astronomical units. However, as Baylor-Jones continued stargazing, complications arose. The encounter speeds of these candidate stars were relatively high, ranging from about 6 to 16 kilometers per second. A possible challenge is that Oumuamua is probably a planetesimal, a small body cast out during the formation of planets. It's rare for planetesimals to achieve such high ejection speeds solely through interactions with giant planets. While these speeds are high, they are not impossible, just very unlikely. The scenario becomes more plausible if Oumuamua originated in a binary star system. However, none of the candidates were identified as binary stars. Luckily, forthcoming data sets from the Gaia mission could help astronomers pinpoint a more suitable origin for Oumuamua by providing deeper insights into the movements of nearby stars. In a few years, it would be interesting to revisit this case, the first and so far only extraterrestrial visitor we've observed crossing our solar system. Despite the limited data available, specialists worldwide are captivated by Oumuamua's potential secrets. Indeed, Oumuamua continues to fascinate due to its unconventional traits. Now, it seems that Oumuamua is not alone. On August 30, 2019, Gennady Borisov, an amateur astronomer at the Margot Observatory in Crimea, detected a new comet named 2I/Borisov. This comet was racing through space at a staggering speed of 93,000 miles per hour, 150,000 kilometers per hour, faster than what you'd expect for an object originating from another star system. Australian 80 away from the Sun, what grabbed our eye other than its speed was its direction. It was diving into the inward nearby planet group at a point of 40 degrees relative to the ecliptic plane, on an orbit marked by an incredibly high eccentricity of 3.7. This showed that, like Oumuamua, Borisov likewise had an extrasolar origin distinct from our nearby planetary system. Borisov showed an unmistakable tail, clearly marking it as a comet. Its venture was taking it toward the Sun, projecting to reach its closest point on December 8, 2019, at around 2 AU from our star. This meant it would brighten before dimming again, perhaps reaching magnitude 15 by its closest pass to Earth on December 28. Even after it dimmed for amateur observers, experts could continue tracking Borisov until October 2020. Dr. Mee's team first observed Borisov and estimated its size to be somewhere in the range of 1.2 and 10 kilometers in October 2019. They noticed the emission of CN gas from its surface, though the comet's faintness prevented detecting other gases. However, the long year of observation, provided by its trajectory, offered an extraordinary opportunity to explore its science. This stands in contrast to Oumuamua, which didn't allow for detailed chemical analysis due to potential hindrances from gas and dust. This extended observation will shed light on Borisov's characteristics. What sets Borisov apart is its distinct comet-like appearance, making it a red-tinted traveler that aligns more with our conventional understanding of solar system comets. This dissimilarity highlights the variety in interstellar objects, which is significant for astronomers attempting to understand the processes shaping other planetary systems, whether similar or distinct from our own. This ongoing investigation expands our perspective on the broader universe. Meanwhile, some astronomers have ventured to suggest that Oumuamua may be of extraterrestrial origin. Adding to the intrigue, a draft article by a Harvard scientist and the head of the Pentagon's UFO office proposed the possibility of an extraterrestrial mothership within the planetary system, dispatching microscopic probes akin to dandelion seeds to explore the planets. The disclosure of this document came from Sean Kirkpatrick, the head of the Pentagon's All-Domain Anomaly Resolution Office, AARO, established in July 2022 by the Department of Defense, DoD, to identify and investigate mysterious objects. Collaborating on this draft study with the DoD was Avi Loeb, an astronomer at Harvard University. However, it's important to note that the study is not an official Pentagon document. Loeb is famous for his research on Oumuamua, having even proposed the possibility that Oumuamua may be an extraterrestrial spacecraft. 6 months before Oumuamua's close approach to Earth, a small interstellar meteor, around 3 feet in diameter, struck our planet. Although unrelated to Oumuamua, this meteor, known as IM-2, caught Loeb's attention. Loeb considered the probability that an artificial interstellar object could act as a parent craft, releasing numerous small probes during its passage near Earth, an idea comparable to NASA spacecraft missions. The tidal gravitational force from the Sun or the craft's propulsion might separate these dandelion seeds from their parent vessel. In their draft study, Loeb and Kirkpatrick delved into unidentified anomalous phenomena, UAPs, a term preferred by the government for UFOs. While adhering to established physics, the scientists speculated that the dandelion seed probes could travel to Earth for observation without being detected by telescopes, likely due to their small size, which would limit their sunlight reflection. According to their proposal, the technology of these probes could enable them to slow down in Earth's atmosphere to avoid burning up, using their parachute-like structures to navigate to their intended destinations after landing. Logical conjecture suggests that extraterrestrial civilizations could seek to study rocky planets with atmospheres within our planetary system. Planets like Venus, Earth, and Mars would undoubtedly pique their interest after detecting signs of liquid water. The mothership wouldn't necessarily have to be home to the advanced extraterrestrial civilization that created the probes. The possibility of the mothership communicating with these probes is too speculative. The idea that a habitable planet with intelligent life could have dispatched probes well before Earth existed is a fascinating proposition. Loeb compares it to periodically checking our mailbox for accumulated packages, even if the senders are no longer living. Loeb has faced skepticism from the scientific community since he first proposed the idea that Oumuamua could be an alien spacecraft. Some critics view his hypothesis that Oumuamua was purposefully sent to Earth as provocative and lacking a solid foundation. In 2021, a letter published in the journal Cosmology and Astrophysics refuted the feasibility of interstellar travel, citing the cosmological timescales required to traverse between stars. The authors concluded that it's unlikely Oumuamua was sent by an extraterrestrial civilization, more likely attributing it to an unusually shaped rock that happened to wander into our solar system. Another study has recently debunked the idea that Oumuamua's puzzling movements could be attributed to an extraterrestrial spaceship. Instead, it offers a plausible explanation, suggesting hydrogen off-gassing, which occurred on March 22, 2023, as the likely cause of its peculiar behavior. However, recent times have seen the Pentagon renewing its focus on investigating mysterious aerial phenomena within American airspace. Since its inception last summer, the All-Domain Anomaly Resolution Office, AARO, has launched over 360 additional investigations into reported encounters with unidentified aerial phenomena, UAPs, by U.S. military personnel. Around half of these cases have been attributed to balloons or similar objects, while the remaining half lack sufficient data for a definitive determination. In the quest for understanding, figures like Elon Musk hold the hope that advanced telescopic scans could reveal more extraterrestrial objects. These discoveries could provide valuable opportunities for researchers to test their theories. The parallels with exoplanet discovery offer an encouraging precedent for such efforts. Just 20 years ago, the first exoplanets beyond our solar system were discovered. In just 20 years, our understanding has expanded dramatically, confirming the existence of over 4,500 exoplanets. This trajectory highlights the rapid progress made in the field of celestial research.